Oh, you're the best. So we're going to look at the chain rule. Chain rule, we put one function inside of another function, and we take the derivative because it's calculus. We represent that this way. So y is equal to some function of another function of x. In other words, we're going to take our value of x, we're going to put it into some function u, and then we're going to take what comes out of that and we're going to put it into f, and that's going to tell us what the y is. Just so you know, this is another way of representing that composition of functions. This means put x into u, take what comes out of that, and then put it into f, and take what comes out of that, and that's what your y value is. Yeah, so anyways, I really shouldn't use f and u for these functions, but this is where we're at. Here we go. So calculus is all about taking the derivative, and the derivative is all about rates of change. And so if our inside function is changing 3 times as fast as x is changing for a particular value of x, and y is changing 4 times as fast as the outside function is changing, how fast is y changing with respect to x? And so if you're thinking 12, good for you. Yeah, x is just changing 3 times as fast as x. Y is changing 4 times as fast as u, the next function out. And so all that really is 3 times 4. And so if we look at that this way, we can say that the rate of change of y with respect to x is equal to the rate of change of u with respect to x times the rate of change of x with respect to, oh boy, I just messed that up. Look at that. Because it's the rate of change of y with respect to the function, which in this case is 4, and the rate of change of the function with respect to x. There we go. And it even has this look of having the du's cancel out. Anyways, this is our formula for the chain rule. So it's mostly just a matter of figuring out what the outside function is and putting it into this little formula. Okay, so let's do 2 examples. Really quickly. So here is our first example. So this is y is equal to square root of x squared plus 4. What we need to do is we need to find our inside function and our outside function. And I am just going to say that my inside function, u, is x squared plus 4. And I'm going to say that y is equal to u to the exponent 1/2, because that's what these radical functions actually look like. Okay, so remember we have to find dy du, and we have to find du dx. So I'm going to find du dx, the derivative of u with respect to x, and it's just 2x. And I'm going to find dy du, which is just the derivative of u. The derivative of y with respect to u. So this is u, 1/2 u to the exponent negative 1/2. Now I'm all ready to say dy dx is equal to dy du times du dx. And so this is 1/2 times u to the exponent negative 1/2 times 2x. But it's not good enough because I know that u is some function of x. And so I'm just going to substitute this back in. It's equal to 1/2 times, and u was x squared plus 4 to the exponent 1/2, and that is times 2x. To the exponent negative 1/2. Now I'm ready to tidy this up a little bit, so I'm going to do a little bit of simplifying. And this becomes x over x squared plus 4. And I could put to the exponent 1/2 underneath here, but I'm going to return it to its radical roots. Okay. If you like, you can separate everything out into this u and y format, and then you can find du dx, you can find dy du, and you can do the substitutions. Or, if you prefer, you can just identify the inside functions and just apply the chain rule. So you don't have to follow this identifying u format if you don't feel like it. Okay, let's do one more example, because it's a little tricky. Not that tricky, but maybe a little tricky. So y is equal to 5 over x squared minus 7. Okay, and it looks a little bit homely because we don't know how to deal with this. Well, we just really don't want to deal with this x squared minus 7 on the bottom. So let's reform it a little bit. And let's turn it into x squared minus 7 to the exponent negative 1. Now, this is going to be a little bit simpler if I choose x squared minus 7 as my inside function. And so I'm going to say, oh, I'm going to choose my u to be this, u to the exponent negative 1, 5, a constant, times u to the exponent negative 1. In other words, I've said u is equal to x squared minus 7. And I'm going to do du dx right now. Du dx is equal to 2x. Okay. Now, dy du is going to be equal to the derivative of this with respect to u. And so just using my power rule, dy du is equal to negative 1 times 5 times u to the exponent negative 2, which is just negative 5 over u squared. And so dy dx is equal to dy du times du dx. Oops. And dy du is negative 5 over u squared, and du dx is 2x. And I'm all ready to go back and do my substitution because I know that u is x squared minus 7. So it's negative 5 over x squared minus 7 squared times 2x. And I can just simplify this a little bit further to become a negative 10x. Okay, so to summarize, that's the chain rule. The chain rule is used when we have a function inside of another function. And we do that just by multiplying the derivative of the outside function with respect to the inside function by the derivative of the inside function with respect to x. You do not have to go through this identifying the u and taking du dx if you don't want to. Sometimes it's a really good way to start out, though, just to keep yourself grounded. And that's the chain rule.